ago, and we are here to check the workability of our work. We have our MCCB DC breaker. Let me show you. Can you see? So we have our MCCB DC breaker of 120 amps, and it can accommodate a load of 8,000 volts. Same here. And we have our AC breaker here for the whole house. We have our AC surge. This is our AC surge. We have our DC surge, and we have two, can you see, AC breakers serving each inverter. So here we have our Cworth 12 kilowatts hybrid, 12 kilowatt hybrid with 20 kilowatt battery powering the whole of the house, and we have 20 panels up there. So from our readings here, let me show them the readings. As currently 400 volts is coming in. We make sure that the voltage is more than the nominal voltage. This is the master inverter running on PV1 and PV2. Oh, can you see? We only use PV1 slot, and 50 amps is coming in, charging the system. The load is 220. Here, these are our slave inverter. Currently, the PV coming in is 2.5 kilowatts. That's why the fact that the sun is not much. You can see us that the sun is not much. Let me now check the load output. The load output is just 1%. The load output here is just 1%, meaning that we are consuming 1%, that's 10 watts. This is also consuming, the major reason why it's wrote minus 31 watts is that it's supplying this. So the total wattage going out is just 20 watts. And the system is generating a lot of energy currently. The system is generating 2.8 kilowatts here and 2.8 kilowatts. 2.8, let me check here now, 2.82 kilowatts here. So the system is running perfectly. This is our DC bus bar where we parallel the batteries. So it's at 46%, and this is also at 36%. So since the parallel system, even if any of the inverters shuts down, if any of the battery shuts down, it will still work perfectly. So if you need a system like this, you can call us on 080-380-15711. And if you're outside Nigeria, add Nigerian country code +234 80-380-15711. It's just a range of 16 million. Thank you very much, and stay blessed.